My Response to Climate Change by Jordan Dudwell. Throughout the course of history, there have been many natural factors that have caused climate change, such as the sun, volcanoes, Earth's orbit, and CO2 levels. With that in mind, it was assessed that the dominant element that caused global warming was human activity. Firstly, how much and how energy is reaching the Earth. A total flow of energy in the Earth's atmosphere is speculated to be around 170 petawatts. The temperature of the Earth is accumulated by the relationship between the incoming radiation that the Earth absorbs from the sunlight and the radiation it emits back into space. A recent study indicated approximately 30% of sunlight is reflected back into space. Conversely, the energy falling at every 1 meter squared of the Earth's atmosphere is about 340 watts meters to the power of 2a to the minus 1. In order to reach an equilibrium, the incoming and outgoing energies to the Earth's surface must be minus 15 degrees. In contrast, recent studies have measured the Earth's surface to be 30 degrees more than what it should be. This diagram conveys what the greenhouse effect is. The air absorbs the longest wavelength. Next, the infrared radiation is emitted by the Earth, and as a result, small amounts of radiation escapes into space. The air in a clear sky is nearly transparent to the visible wavelengths coming from the sunlight. This absorption comes from several minor atmospheric constituents. This process warms the Earth's atmosphere, leading to the lowest 10 kilometers of the atmosphere, which is called the greenhouse effect. The greenhouse gases warm up the surface by a staggering 30 degrees Celsius. Nitrous oxide, carbon dioxide, methane, and chlorofluorocarbon are the gases that make up the greenhouse effect. The Industrial Revolution was a monumental part of history that changed the dynamic of climate change. Huge amounts of fossil fuels were burnt, and since the beginning of the Industrial Revolution, over 600 million tons of carbon has been emitted into the atmosphere. The major source of human-produced greenhouse emission, accounting for approximately 65%, is burning fossil fuels. It is highly probable that there will be an increase in methane concentration due to anthropogenic activities, predominantly agriculture and fossil fuels. In 2011, the emissions for methane were 10% higher, with a higher rate of breeding. Furthermore, the global atmosphere of nitrous oxide concentration increased from its pre-industrial value of about 270 ppb to 320 ppb in 2013. As well as methane, nitrous oxide emissions are set to increase. This is because of many reasons, such as the tropospheric ozone and the change in the surface of bead. A major factor in emitting greenhouse gases is volcanic eruptions. In 1991, the second largest eruption of the 21st century occurred in the Philippines. Mount Pinatubo erupted, and the height of the ash plume reached 28 miles. The eruption equated to 10 million tons of sulfur dioxide emitted into the atmosphere. Additionally, the eruption reached the amount of sunlight reached the Earth's surface to around 10%. The OECD. This leads me to projections and the past. What are OECD doing, and how are ice cores helping us with key information? The OECD are a progressing company with their goal being to achieve a decrease in the average global temperature. They have projected for 2050 for a 50% chance of sustainability. Continued, the average global temperature increase at 2% over the pre-industrial period if we keep CO2 concentration under 450 ppm. We are able to check the past elements of climate change through ice cores. This includes the surface temperature and the atmospheric chemical composition. Deep ice cores from Greenland and Antarctica provide additional evidence for element change and atmospheric concentration. This goes stretching back from over 800,000 years. The main consequences of climate change. There are multiple consequences of climate change, such as warming, extreme temperatures, extreme precipitation, snow covering agriculture, tropical cyclones, sea levels rising, drying, and ocean acidification. Here in the UK, we are set to see wetter winters and greater precipitation to fall as heavy events. Also, there is an expectation of drier summers. Here is a diagram of the projection for the surface temperature. As shown in the diagram, majority of the regions are in the red zone. The next diagram is a projection of precipitation change, with all regions being over 20%. This brings me to the debate around climate change. There are 4 different political perspectives in climate change. They are the skeptic fringe, skeptic centre, supportive centre, and the eco-traditional. To add on, there are 2 types of business markets. The first being traditional free market business, which prioritise how much profit is being made, and the alternative one is the ethical business, who are concerned with how profit is made and how much profit is made. However, there are other concepts that organisations need to embrace to future-proof their business. These concerns are over a global shift, a rise in emerging world economies, a declining trust in corporations, and a stakeholder demand for social value. This leads me on to the Paris Agreement, which was signed by 196 countries in 2017. This empowered them to have a lot of guidance that the NDC must succeed from their previous targets, and they must be ambitious. Also, they must report back to the NDC every 5 years. What to do to tackle climate change? Surprisingly, 1.7 Americans believe it is too late to do anything about climate change. However, they are wrong. There are multiple ways to tackle climate change, such as loft insulation, super efficient LED lights, micro CHP combined with heating and power systems, which can cut down carbon emissions up to 20%, as also household waste collected to feed CHP systems, ground source heat pumps can cut bills by 425 per year, and double glazing and shutters, and solar thermal panels to produce hot water. However, there are also ways to tackle climate change on a larger scale. I have chose 2 ways, and my first one is ocean pumps. Ocean pumps, phytoplankton, use energies from sunlight to fix CO2 into organic carbon. Most organic carbon is consumed and respired in upper ocean organisms in the upper ocean which die and transport organic carbon nutrients to deep ocean. Some organic carbon is buried and incorporated into the main sediments. Bions hold pumps in a position as a large scale of tubes access deep water, which is drawn to the surface by water action. Core nutrient rich water spills out the pump. Algae blooms at the surface, and algae consumes CO2 through photosynthesis. My second way of tackling climate change on a large scale is synthetic trees. Synthetic trees planting absorbs CO2 and a major eco-industry. An alternative is synthetic trees. Synthetic trees would act like filters, removing CO2 from the atmosphere. An absorbent coating, e.g. a lime water, on the slats or leaves would capture CO2 and retain the carbon. Carbon can be stored, e.g. for example in agriculture or empty North Sea or oil wells. One synthetic tree could remove 90 tons of CO2 per year. This brings me to my carbon footprint. Why should we report on our carbon footprint? A reduction in emissions, mainly due to an increase in the use of coal for electric generation. China is the largest country to emit CO2. For fossil fuel combustion and some process, also businesses disclose their emissions. The benefits: there's lower energy and resource, better understanding to exposure to the risks and help strengthen your credentials. So I accumulated my carbon footprint, and here are my results. For a light bulb it's 100 watts and I use that 3 hours a day, so that's 300 watts. A kettle accumulated to 60 watts per day. A fridge accumulated to 1.5 kilowatts an hour, and I live in a household of 4 people, so divided by 4 is 375 watts. A shower for 10 minutes is 7,500 watts. A computer 100 watts, I use that 4 hours a day, which is 400 watts. And a washing machine is 500 watts, assuming I wash my clothes 2 times a week for 52 minutes. And the final one is a cooker, which uses 1,200 watts for 30 minutes a day. I summed up my carbon footprint, and it averaged to 3.6 tons of carbon a year. That is nothing near the average of British carbon, which is 10 tons a year. Thank you. These are my references. Thank you.